question number 3, we're going to let R be the region in the first quadrant enclosed by the graphs of f of x equals 8x cubed and g of x equals sine pi x as shown in the figure next to it. So for letter A, we're going to write an equation for the tangent to the graph of f at x equals 1/2. So we just need to write the equation of the tangent line. So first we need to do the Poisson formula, which is y minus y1 equals m parentheses x minus x1. So now we need to plug in, we need to find the x and the y, x1 and y1, and the slope. So they already gave us the ordered pair, which would be our x1 and y1. And so when we plug it in, it's going to be y minus 1 equals m parentheses x minus 1/2. But we still need to find our m, which is our slope. But in order to find that, we need to find the value of the derivative at that point. So we know that f of x equals 8x cubed. We need to derive that to find our slope. So pretty much we're going to do f of x equals 8x cubed. We're going to derive that. And it's going to be 24x squared. So pretty much we're going to plug in this to this. This is going to be, let me do it over here. So it's going to be f 1/2 1/2 2. So which will then become 24 1/4, which will equal 6, which is now our slope of tangent line, or m actually. So pretty much now we just need to plug it into this problem that we already had initially. So it will be, so y minus 1 equals 6 x minus 1/2. So which this will technically be your equation to the tangent line, or you could just break it down even further and just leave it as this. But either way, they mean the same thing. So pretty much that, we only need to find the equation. We don't find anything else. And so pretty much either one of these two could be your answer, and that will be the answer to. So for letter B, we need to find the area of R. So now we just need to keep in mind which line is F and which one is G. So F is on the bottom right here, and G is on the top. And pretty much to find the area between the curves, you need to do the integral on the top minus the curve on the bottom. So first of all, we're gonna have to do the top minus the bottom. And when we finally plug it in, we're just gonna use g of x from what they gave us and the f of x. And so when we plug it in, it'll be the integral between the 0 to 1/2 sine pi x minus 8x cubed dx. So pretty much we just need to solve it, and what we need to do is take out the pi to cosine x 2 b. Then next we will do pi cosine sorry, this is to the 4 minus so what you see here is that we just plugged in the ordered pair, the 1/2 and oh no, we didn't plug in the ordered pair. We plugged in the boundaries, which we see the 1/2 over here and the 0. And pretty much when we solve this, we will get this will just become negative 1/8 plus 1 pi, and pretty much this will be the area between R, and you could also do substitution, but I decided to do it this way because it seemed easier for me. And pretty much after that, the area will be this. the area for R.
For letter C, we need to write, but not to evaluate an integral expression for the volume of the solid generated when R is rotated about the horizontal line y equals 1. So pretty much we know the horizontal line will be across the point 1/2 and 1. And well, we already have a formula to plug it into, and that will be pretty much the integral expression we need to find. But it's based on the... So pretty much this is the formula we need to plug it into. And we already know what little r and big R are. So big R will be R equals 1 minus f of x, and little r will be R equals 1 minus g of x. So to plug it in, we already have our f of x and we already have our g of x. So pretty much when we plug it in, it's gonna look something like this, and which is pi, the integral between 0 to 1/2, and in parentheses 1 minus 8x to the cube, another outside parentheses, close parentheses I mean, square minus 1 minus sine pi x and square dx. This will be our integral expression to find the volume.